Hey everyone, I'm Jack. Uh, hope you had a good night. Today I'm going to take a look at this problem, the 1039 minimum score triangulation of polygon. How should I pronounce this this word? Poly, poly, pod, uh, Polygon. Yeah, polygon. Yeah, polygon. Given n, consider a convex n-sided polygon with vertices labeled, suppose you with clockwise order. Okay, suppose you are triangulating the polygon into triangles. Yeah, we have a lot of options to do that. So for each triangle, the value of that triangle is the product of the labels of the vertices. So the sum of the product, yeah, the multiply them all, and the total score is the sum of all the value of the triangle. Return the smallest possible total assets. So this is an example 3, 7, 4, 5. We have these two possible options to just divide the triangle. So each of them, so we have the first option is 245, the second one is 144, minimum is 144. Okay, and they're max 50 points, and for each point the value is maximum 100. So actually I've been thinking about this problem for like 2 or 3 days, and I haven't got it. I haven't got a better really understood it until just now. It's because this is the first recursion is very easy, but it's very simple, but it's very prone to lead to the time limit exceeded. Let's take a first look at how we can solve it. This is a sketchpad. I just searched on the internet, and let's take a look. First, I'll change the line to line. Okay. So this is, suppose, polygon, and say if we are doing it in a recursion way, we say, okay, for there are n points. So let's take the first one. So this is one is let's say this one is 0. Oh, this is so big. Okay, let's just pretend this one is 0 and this one is the last one. Okay, so for the 0, there's one possibility that we just cut it like this, and then the problem becomes this triangle we can calculate directly, and the rest, right? And for the second one, we can also do that, right? Yeah, so this is a for loop, and then let's say for this new polygon, we can also do it the same way. So for these are the lines, and then we cut it like this, and then do it again and again. So it's very simple. Let's try it. Actually, it's very simple. You just return a map. Should we do map or for loop? Oh yeah, let's say the minimum is infinity. For its I equals 0, I is smaller than a dot length, I plus plus. So when we cut it, we'll calculate the rest. Right. It's very simple. We just say when we cut it, we have to calculate it what the product is, right? We cut to the last one, it should be these three. So Oh, okay. So if so, the cut indices equals, if I equals 0, there are, if this is 0, so it should be 0 and these two, right? So indices should be cut. I just say it's the product. Yeah, it should be a 0 times a 1 times a dot length minus 1. Or I equals okay, the last one. Yeah, a dot length, if the end is cut, then should be 0. Yeah, so it should be 0 times a dot length minus 1. Actually, a length is so much use. We create a called a dot called total to reuse this variable. It doesn't help much, but it can reduce avoid writing too many verbose declarations. So if it's not the first and not the end, we can just say a I times a minus 1 times a plus 1. So this is the cut. And min should be math. For each cut, we should calculate the min. And so we can just actually calculate it again. A slice, we copy it and then splice it. Splice the I, right? 1. Okay, sorry. It should not be sliced. Actually, rest equals I the slice. Rest splice, we remove it, so it should be I1. Actually, we can call it this main score triangulation. This one. Oh, this is rest. Yeah. Main is this. Okay, return main. What do I have? Nothing. It's okay. So main, this is the main, and this is the 4, and return. So we can actually finish it. Oh, sorry. Math main score rest. I think there would be no problem. Sorry. Shit. Plus total. And sorry. If total equals 3, we just return them all. Return the calculation. 0 times a2. Run the code. 6. Okay, so actually this is my trial like 2 days ago, so we can ignore that for now. Actually, this is our first trial. And for the 1, 2, 3, it's very simple, and we get the right answer. But now for 3, 7, 4, 4, 5, we got an error. Wait a sec. It should be no. So every time we cut a number, yeah, and oh, this is wrong, maybe. No. If the cut is 0, so we calculate the 0, 1 total. Yeah, that's right. Plus spice the first one. Yeah. If it's total, I'm sorry. So this here should be -1. No. If it's total 1, so it should be I minus 1. Okay, if the other one just update the yeah, and the rest we copy the array and we splice the I position, and then calculate the rest by recursion and plus the total. Shit, it should be cut. Oh yeah, okay, let's submit again. Yeah, you see that we got this error, the time limit exceeded. So actually we are getting the wrong, we are getting the right answers, but it's too slow. Let's look like this. It's like we can see that this part. Let's fit it with red. Oh shit. Cannot be fit. Oh, anyway. So this area, these 4 dots, this area was calculated by within these polygon and this polygon. So actually the recursion doesn't cost so much because we calculate again and again. We need to do something by memorize it. So I'll try create another function by memorizing. It's just main triangle a memo. Just name it cache. Okay. So actually const key equals a to string if cache key return cache key. So it may be 0. It cannot be 0, so we just cache return it, and we cache it cache key equal me. So actually we are return main cache. Add the simple cache to cache the result. We will see whether it helps or not. Yeah, time limit exceeded. Actually, I'd like to see how much time it costs. So actually, let's do here const start console log. Yeah, start equals date. Now we'll copy this input. Console log date now. Let's start. But first, we do it without cache. Okay. We run the code. Maybe take us several minutes, but let's wait. Sorry. I shouldn't do it like this. Okay, run it again. Actually, I didn't figure this out by myself. I tried a few times and there's still console log. What? Wait a second. Okay. There's no console, right? Yeah. I'm not submit, but run the code. Shit. Okay. We will run it in our browser to see. Okay, so we call it with this. Yeah, let's wait a few moments. I think maybe it could take us like 30 seconds or 40. Oh, it's definitely longer than that, maybe within a minute. Wow. Wow, 2 minutes? This is only on browser, so maybe the performance is not that good. Anyway, let's wait. Sorry. I just want to know how much time we can save by memorizing the data. While we're waiting, we change to while we're waiting, we'll change the code. It's actually freezing, so it's too much calculations. What we gonna do? Yeah, actually we're waiting more than 2 minutes. It's too much. We just reload it. Okay, give it up. Oh shit. Actually, our browser is frozen. Actually, oh, I made a huge mistake. I'll kill the process. This one, right? I think this is what. It's taking down my computer. I reload it. Okay, so without memorizing, we know that it's definitely not gonna work. Okay, and we will try memorizing it. Try it again here. I don't think it will take too much. We will help us much, but let's take a look. This is our previous submission. This is the to make things simple. We try this one. Huh? Take 0. What? Is that fast? No. It's not. Oh, okay. Actually, this takes us 9 seconds. You see? 9 seconds. Okay. Even though we already cached it. Oh, sorry. We didn't make it right. I will try it again. And actually, 9 seconds. I'm not sure whether the time limit. So actually, we were saving a lot of time by memorizing it. Yeah, cool. undefined. Oh shit, we didn't return. Shit. Okay. Close the console. Yeah, we still got time limit exceeded. The problem is actually, after digging it out by referring some articles, understand it. We take a look at again at the polygon we drew. Sorry, it's gone. Okay, here. Actually, there are too many keys. We're just taking the array into the keys. Like there will be so 0, 1, 2, 3, 4, 5, 0, 1, 2, 0, 1, 3, 0, 4, 5, 0, 1, 6, right? So what's the possible amount of keys? It's actually as for each dot there will be in it or not, so it will be 50. Wow, that's a lot of keys. So actually it's not gonna it's not very good to save the keys. We need to think another way. Is there a way we can stop using the keys by transforming the array to strings? Yeah, actually, let's take a look why we. The instinct tells us we can do something by setting the start and end, right? Like for this triangle, this is start and this is end. Yeah, and for these polygon, this is start, this is end. But actually, these are some problems. Is that we have these kind of triangles. It's actually scattered on the border, so it's not consecutive dots. That's a problem. We cannot do that. And what are we gonna do? What we gonna do? It's actually, I got the answer, but it's not from me. I just thought it's for clever. So you see that the problem is that we have these scattered things to forbid us using start and end to define the borders of a polygon. So what if we can? So each time we drew a line, currently currently when we cut the polygon, we cut by these triangles, right? Okay, so each time we cut the triangle, and then we cut the triangle, and then we cut the triangle. So this leads to these triangles without consecutive dots in the original border. And there's another way we do this. We take this border as a basic. So the things coming to our minds now is that, okay, we randomly pick up the first dot and the last dot, so we take the border of it. So the possibilities for this border as a triangle will be in this triangle, right? Or this triangle. Together, a triangle is defined by a border and the counterpart dot. So this triangle or this triangle, right? It doesn't matter what the border is. It's just if we take one border and there would be n minus these two dots minus so minus these two dots, so there will be n minus 2 possibilities for these triangles. So we only need to take into considerations of these cases, right? Okay, this is the last case, and this is the first case. So what's the point of this? What's the point of it is that every time we are creating a triangle with the border on the border and a dot, right? So with this case, we can always keep the borders at the original border. It's like, so if we cut this polygon with this triangle, and we see for this part and this part, the new except the new border, the original border is still on the board, on the original border. So now we take in, so this triangle we can just calculate the sum, and for this border we are doing it just recursively like this, and then yeah, everything's cool. Why the borders are there? You see that in the original solution, we cut it like this, right? And this leads to a problem. Is that we just leave new we may end into polygons with two new borders. You see, if we cut from this dot, we'll have two new borders, this new one and this original one. If we cut it by already a triangle, for this triangle we can calculate the sum. So, and for the rest, we always keep it only one new border. That's why we can assure the rest polygons can be defined with a start and the end. So start here and here, start here and here. So we say it in the clockwise way, and we cut it new. Just to say, if suppose that there's a more dot, and this is new border, so we cut it like this, and we can still calculate by recursively the rest, this triangle and this triangle. So we actually have a new way of doing it. We kept the cache, and actually we have a start and end. So this recursion, it's still in a recursion fashion, and the start and end. Let's say key, cache key. This we keep it, and min is infinity, total is length. So we actually don't need to cut. Wait a minute. Const length equals end minus start plus 1, right? If length is more than 3, return 0. If length equals 3, return. So if it's only 3 dots there, we just return a start times a start plus 1 times a start plus 2, and it's the same. Okay, so the other case, they are not a triangle. We have to do it recursively with a for loop. Yeah, so a for loop is start from, we already keep the start and end, so it should be I start minus 1 plus 1. It's more than n, we plus it. So we every time we just calculate by 3 parts, the new polygon, and the triangle. So we say we keep the main, let main equals infinity, and min equals max min. This one is the same, min, and okay, so actually we the first polygon, this is the I, so I start n, so it should be we call this again tree a start I cache, right? Plus min tree a I end cache plus the triangle in the middle. So it's a start times ai times an. So this is the cut and the min. So for this polygon, we recursively check the minimum product. So this is the min, and we set it to cache, return it, and it should be working. No. Main has already been declared. Sorry. Oh yeah. Start is not defined. Where? 9:30. Shit. Okay, we're getting the right answer in a small data set. Submit it. We got the wrong answer. What? Okay. Start I and cache start I. So it's 39. We can get 13. We will debug it by here and console log. Console log key. So it's one. Console log start 05, yeah, 01. Yeah, it should be 0. Okay, so 1 to 5. Okay, 1 2 0 2 5, and then 2 3 3 4 2 4. So this one minimum is 9. Why the mean of for this case 9? Ah, shit. Actually, the key isn't right. We set it A and start with N. We need to calculate the key. We say the key is just a start like this. Okay, yes, we make it yeah, this is right. Make it a string. Okay, we get the right result. It means that our this new cut method works, and it runs at 96 milliseconds. It's faster than 25%. We can actually improve it by what? By and yeah, this key, we got two variables, and we're using this composition literal template to create the string key. Maybe we can change it. Let's say start, because it's smaller than length, smaller than 100. So we just say we make it this, make it a key, a number. I'm not sure whether it's faster. Wow, it's faster. It's already faster than the whole. It's faster than all the solutions. Cool. And actually, I remember that if we're checking the cache by object, so by property, the object doesn't work better than new map. So I'll say the new map, use map to get it. So cache pass key get key, cache set key. We submit again. It's slower. Shit, I don't know. Why it's slower? Maybe in these cases that the new costs more time. Anyway, it's only one time, so it would be, we wouldn't have so many. Wouldn't cost so much, I think, if the cache is cost cache equals cache get key cache return cache. Let's try this. Maybe the it's the same. Well, sometimes map doesn't work that fast, it seems. Shit. Just remove it. It's not that stable. Sorry. Made a mistake. I want to move back to this 45 second. I think it's the same. Yeah. Mm-hmm. Okay, so I don't know. So it's not that we cannot trust the time so much. I think new map will help us. But it turns out not. Um, anyway. Hmm. This is the other solution I did. It's actually the same. We use the map to cache it. It's actually the same. Yeah, anyway, we cannot get faster, I think, because these are all this guy. Wow, this guy is fast. Anyway, I think we're done here. So the most important part is that we need to divide in a way that we can suppress the use of scattered points as key. We keep the dots consecutive in our original border, uh, so we can minimize the key by just doing some simple calculations like this. Okay, so that's all for today. Thank you for listening. See you next time. Oh, thank you for watching. Sorry. Have a good night.